Hello, ladies and gentlemen. I hope you guys are doing well. Welcome again to this next episode. So today we're going to be talking about this question. So the question reads: a 5 kg block is placed on top of a 12 kg block that rests on a frictionless table. The coefficient of static friction, which is mu s, between the two blocks is given as 0.6. What is the maximum horizontal force that can be applied before the 5 kg block begins to slip relative to the 12 kg block? If the force is applied to A, the more massive block, and then B, the less massive block. So here we've got two situations. We are told that we've got two blocks, one sitting on top of the other, and then these two blocks, they are going to be moved at different instances. For instance, the situation A is saying we are going to calculate the maximum horizontal force that needs to be applied before the 5 kg block begins to slip relative to the 12 kg block when we apply that particular force to the more massive block. So what we have here, we have a situation whereby we have to, so that's why you see me now drawing something like this. So this simply means that we've got a smaller block and a bigger block, and they are actually sitting on top of each other. So in the part A, these are the freeboard diagrams for part A, and then for part B we'll focus on it on the other side. My board is so small, so I will just try to make sure that I squeeze in everything here. So what's going to happen is that if we apply the force, if we pull using the bigger block, if we apply the force through the massive or the more massive block, which is the bigger block, we expect a lot of things to happen because these things, they are directly on top of each other. So we expect to have freeboard diagrams. We need to know what's going to happen to the bigger block, and we also need to know what's going to happen to the smaller block. So if we zoom in to what is going to happen to the bigger block, remember we are going to pull this force. But before we even do anything, we know that since these two things, they are sitting on top of each other, this one is exerting the weight due to gravity, which is the W1 that you can see there, and then you have got the force that we're going to apply to the bigger block. Remember, number one is big block, and then number two it's smaller block. So where you see one, it means bigger block, and then where you see two, it means smaller block. And then since we are going to be pulling this side, and then we know that these ones, they are sitting on top of each other, the moment you start to pull one, since you are told that there is a coefficient of friction between these two, there is going to be some element of resistance when these two start to try and slide. That's why you see now this one is going to be affected. This frictional force is going to be experienced here where these two meet each other, here. So as you pull towards this side, the frictional force is going to pull against. That's why you see here on our freeboard diagram, we've got the frictional force pointing to the left. And then this is the normal force, since it's sitting on the horizontal table. And then since there is a block B, which is block 2, that is sitting on top of the other, it's going to exert the force to the bigger block. And that's what we are saying, the force of block 2 on block 1. That's why you see me writing F21, which means the force applied by block 2 on block 1. So this is what is going to happen to the bigger block. Now if we zoom in as to what is going to happen to the smaller block, now, remember we are going to pull the bigger block. So the moment we pull the bigger block, this smaller block is going to be affected, since we are saying what is the maximum horizontal force that can be applied before the 5 kg block begins to slip, before which means before it begins to slip, the maximum horizontal force that we can apply is the static, it must be greater or equal to the static frictional force. That's why you see the moment we start pulling this, the moment we start pulling this top block is going to be pulled again by the force that is equivalent to the static frictional force before it starts to move. We know most that if we have a static friction and then we are asked to calculate the force that can be applied exactly before something starts to move, that force must be equal to or greater than the static frictional force. Otherwise, if it's less than, it won't move. So that's why you see now we have got the force that is pulling this side. So the moment you pull this bigger block, it's going, as it starts to move, it's going to apply a static frictional force, a force that is equal to the static frictional force for this smaller one again to start also to move. Hence, you see me labeling this force. Okay, and since it's a block that is actually sitting on another block, so we expect it to have the normal reaction as well as the weight due to gravity. So these two are the free body diagrams of what is happening between the two blocks. So if we pull using the bigger block, this is what you expect to have. Okay, so now we need to calculate the force applied, which is our F1. We need to know the value of F1. So what I simply did, I just resolved all these forces. So I took all the forces that are affecting the x-axis in block number 2 here. So the forces that are in the x direction, we have only this one, and then there is nothing on this side. That's why you see me coming here and writing F summation of forces in x of block 2. That little 2 there means block 2 is given by Fs minus 0, which means there is no force that is opposing here. So it's Fs minus 0, and these are supposed to be equal to Ma. Why? Because this thing is in motion. It's going to be in motion. The question has said that. If it was not going to move, if it was just sitting down, we were going to say Fs is equal to 0. But now it's moving, so it's going to be equal to mass times acceleration. So M2A2 simply means the mass and acceleration that is affecting block number 2 there. So for forces in y now, summation of all forces in y is equivalent to, if we look here, we've got N2, the force that is facing up, and then it's going to subtract the weight. So we have N2 minus W2, which is equal to 0. Why equal to 0? Because our system is said to be moving on a horizontal surface, which means there is no moving up and down. Therefore, the acceleration is 0. So if we put Ma, the A is 0. So Ma, it's M times A, which is 0. That will give us a 0. That's why you see me simply writing 0. So if we are to rewrite this, we will then find that N2 is going to be equal to W2, which is going to be equal to M2G. Now, if we are to calculate now the forces that are acting on block number 1, we start with the x-axis. So if we look here, we've got F1 minus Fs, and these will give you Ma. So F summation of forces in x, F1, there you have it, F1 minus Fs, it's going to be equal to Ma. And then summation of all the forces that are acting in y, you have got your N1 that is going up minus the force applied by block number 2 on block number 1, it's pointing down, minus as well the weight of block 1. So that's why you see me having N1 minus F21 minus W1 is equal to 0, like that. Okay, so we should know that the moment these two things start to slide, since they are sort of connected, it means they are going to do that at the same acceleration. Therefore, that's why you see me writing here not A1 is equal to A2, which is equal to A. So we are going to call acceleration, whether it's acceleration affecting block 1 or affecting block 2, it's going to be A. Why? Because acceleration in both instances is the same. They are sort of connected particles. So now, we know most that if we come back on equation 1, if we remove this 0, Fs is going to be equal to M2 A2. That's what you see me writing here. M2 Fs is equal to M2 A2. So this is what we have in equation 1. But we know that A2 is equal to A. Therefore, Fs is equal to M2 A, like that. But we know there is a formula to calculate the frictional force. So Fs, which is the static frictional force, is going to be given by mu s multiplied by n, which is but in this case, since we are dealing with block 2, it's going to be mu s n2, because we are dealing with block number 2. So if we were to simplify that, we know for the fact that n2 is equal to m2g. We have found that here. That's why we agree that n2 is equal to w2, which is also equal to mg or m2g. That's why you see me saying where n2 is equal to m2g. So here we are now just going to equate the values of Fs. Remember, here we've got the value of Fs being equal to mu s n2, and then here we have got the value of Fs being equal to m2a. So if we can equate these two values of Fs, which is m2a is equal to mu s n2. That's what you see me writing here. Fs is equal to m2a, which is equal to mu s m2g. Remember, this m2g is the value of n2. So if you do that now, you can make a subject of the formula. So you have to divide both sides by m2. So if you divide both sides by m2, your a is going to be equal to mu s g, like this. Now we are solving the equation 2. This is our equation 2. F1 minus Fs is equal to m1 a1. So if you are to solve that now, if you take everything to the other side, leaving F1 on the left side, it's going to be F1 is equal to m1 a1 plus Fs, where m1a plus m2a are representing whatever that we have there. But we know that the value of a, according to this statement, a is equal to mu sg. So everywhere where there is a, we are going to put mu sg. So here, which is equal to m1, it's m1. Then in place of a, we put mu sg, like that, plus, this is plus, m2, m2. In place of a again, we put mu sg, like this. So if we look very carefully here, we'll see that mu sg is the common factor. Then we had to factor it out. So if we factor it out, we'll have m1 plus m2, like this. So now you can simply plug in the values, because we have got all the values given to you from the question. So in place of mu s, it's 0.6. In place of g, it's 9.8. m1, it's 5 kg. m2, it's 12 kg. So at the end of the day, if you punch, this is going to be your answer. Okay, it's a very, very, very long scenario, but if you pay very much attention, you actually find out that no, it's actually simple. So that's what you will have for part A. Now we go for part B. Part B now, the question is saying if the force is applied to the less massive block. So the less massive block is the smaller one on top. So that's why you see me there indicating the force being applied on the top block. Remember here, the force was applied on the bottom block. Here it's being applied on the less massive block, which is the top block. So if we do that, we expect to have something like this on our free body diagrams. On the bigger block, since we are going to apply the force on the smaller block, the bigger block is only going to be affected by Fs. As I have said before, that when you are pulling, before it starts to move, the block that you are not pulling is going to be affected by the static frictional force only. So here, that's why you see me having Fs going this side, and then we've got our normal reaction Remember, this is for block 1, the bigger block, this one. So you've got your normal, you've got your the force applied by block 2 on block 1, and then you've got your weight. And then for block 2 itself, these are the forces that you expect to have. You will have the force that you are going to apply, and then you have the resistance, which is the frictional force, going to the opposite direction. And then you have your W2, which is equal to M2G, and then you have your normal reaction. And then if you are to resolve the forces that are affecting these two situations, then you come to something like this. Okay, you come to something like this, whereby if you deal with block number 2 first, you and I can agree that sum of all the forces that are acting in X in block number 2, F2 is going to subtract Fs, and this is going to be equal to Ma. That's what you have here. F2 minus Fs is equal to Ma. And then sum of all the forces that are acting in Y, you have got N2, which is going up, and then you have got W, which is pointing down. So N2 minus W2 is going to give you a 0. So there and there, N2 is going to be equal to M2, it's going to be equal to M2G. This is supposed to be N2, like this. Okay. So now, if you are to now look at what's going to happen on block number 1, sum of all the forces that are acting in X, you have got, on block number 1, you've got Fs. There's only Fs. So therefore, Fs minus 0, there is nothing on this side, is going to give you Ma. Then those that are acting in Y, you've got N1, which is going up, minus these two that are going down. So it's going to be N1 minus F of 2 on 1 minus W1 is going to give you a 0. So F2, if you go back here and recollect, you'll find then that F2 is going to be equal to M2 plus Fs. That's what you see me writing here. F2 is equal to Fs plus M2A, like that. Okay? But we have to again find the value of A. In these situations, there are two things that are common: the static friction and the acceleration. That's why you always see me trying to find A first, such that as soon as we get A, we can use A in both scenarios. So here, in order for us to be able to get the value of A, from the equation that says this one, from equation number 2, where I'm pointing, you can agree that Fs is equal to M1A. That's why you see me here writing Fs, which can be calculated. Remember, the formula to calculate Fs is mu s n. So since we are dealing with particle number 2, it's going to be mu s n2, which is going to be, in place of mu s, we write mu s, and then in place of n2, we know most from the question that n2 is equal to m2g. So in place of n2, I just substituted by that. But from here, we agreed that Fs is equal to M1A. That's why you see me here writing Fs is equal to M1A. But the same Fs is the one that we calculated here again. Fs is also equal to mu s M2G. So you can equate these two to find the value of A. So since Fs is equal to M1A, so M1A is equal to Fs, which is also equal to mu s M2G, because we agreed most that Fs is equal to this. Yeah, we agreed. So if you can equate these two values of Fs, these can allow you to get the value of A. So if I'm to divide both sides by M1, my A is going to be equal to mu sg M2 over M1, like that. So everywhere where there is A, we substitute the value of A by those. So from F2 is equal to, this is our equation that we have here. F2 is equal to Fs plus M2A. So in place of Fs now, since we know the value of Fs can be mu s M2G, that's why you see me writing here F2 is equal to mu s M2G. This is simple, or it's the other way of just saying Fs, since this is the value of Fs, plus M2A it was there even in our equation at first. So if we expand this further, we'll see that F2 is going to be equal to mu S M2G, which is the value of Fs, plus, in place of M2, there is your M2, but in place of A, since we agreed that our A value is going to be this, so I had to substitute this in place of A. Okay, then if we simplify that, since if we can take a look, we can find then that mu S M2G is common in both sides. We have got this, it's also here mu2, so M, mu S and G. So mu ms and G is common. That's why I had to factor mu ms plus G. So that's why I had to factor mu S M2G, because it's common on both sides. So if you factor it out, you have your 1 plus M2 over M1, like that. And then you've got all these given to you from the question. So in place of mu S, you put 0.6. In place of G, you put 9.8. And then in place of M2, you put 5 kgs. And then you open your bracket in 1 plus. In place of M2, you put 5. And then in place of M2, you put 12. And then if you punch on your calculator, you'll find something like this. So this question is one of the longest questions, and it actually needed me to be erasing the body and then rewrite again. But since I do not have my camera stand, it's very difficult now for me to be writing, erasing the body, at the same time holding my camera. But I hope you have gotten the idea. I hope you have gotten a clear picture of what's happening here. All the trick is there on the it's hidden on the freeboard diagrams. So if you can look at the freeboard diagrams very carefully, this question can be very easy for you. Okay, cheers. Let me know if you don't get it, so that I can try by all means to redo it. Thank you. Bye.